This is the second part of our Dismiss the Myths series, where we're talking about all those things we hear about Java EE and Jakarta EE, which just simply aren't true nowadays. In this session, Steve Millidge is going to be talking about the misconception that Java application servers are heavy. So we're going to be looking at creating a fast, small footprint, low resource usage used in our Jakarta EE runtimes, and talking about what you can do to keep things light and how these things work. Cloudy in Germany, very sunny. Belgium, awesome. Great. Are you ready to get going, Steve?
I'll just share, make sure it's okay.
No worries. I'll put a few links in the chat as well, guys, just where you can register for the next ones in the series if you still haven't, or join our media group, so you can always sort of be informed. As always, feel free to put any questions in the Q&A section or in the chat, and I'll feed those to Steve as soon as I can. There will be some time at the end as well, where we'll have time to discuss any questions you have. Brilliant. So thank you very much. Steve, whenever you're ready.
Okay, you're good to go. You can see the slides.
Mm-hmm.
Okay, so thanks, Jaden. As Jaden said, I'm going to explore the question really of, are Java EE application servers heavy and slow, which is one of the things that gets thrown at Java EE by maybe people who don't know much about it or haven't used it for many years. So it's part of a series that we're doing. So we're looking at a number of questions. My machine's not moving forward. There we go. So the first one we did last week was, is Java EE outdated and dead? So we had explored where Java EE is now today, what's happening in Jakarta EE. Today we're basically answering the question, are Java EE application servers heavy? Next week we're taking a look at what is cloud native, which is a very interesting question. Because that's a very confused answer for what is cloud native, but we look at Java EE and cloud native. We then have a look at the exploration of the Java EE deployment model. We look at microservices, and then final one we'll be talking about standards and whether standards sort of matter in a modern development world, and why they do, basically. As I say, we're doing this once a week. Last week we did the outdated one, and this week we're doing application servers are heavy. They're always on a Wednesday. It'll be at 3 p.m. British summer time, 4 p.m. European time, 10 a.m. Eastern. Same place, same time each week, so you can easily remember. And if you want to sign up for them all, you can, or you can pick and choose which ones you're interested in. So let's dive into the topic of this webinar. First, the question, as I said before, is, are Java EE application servers heavy and slow? So first thing I'm going to do is actually break down that question. And first, let's look at what is an application server, because this gets quite a lot of confusion out there. Many things people say, oh, you don't need an application server. What you need is Tomcat or something, which by definition is the same thing. So let's explore what is an application server, and then I will also explore a little bit about different application server deployment models that we have nowadays. So this is a picture of my view of what is an application server. So the goal of an application server is basically to provide and manage runtime for your application. So your application is the jigsaw piece at the top there, and what the application server provides is a whole load of services for you. So services that you wouldn't have to write yourself. So these include things like how to handle thread management in the server, how to basically do HTTP processing, which isn't on there, how to do network handling, socket handling, all the socket selects, and all the other things you need from a networked application. It does database connectivity for you through data sources. It can generate metrics, monitoring, diagnostics. It provides subsystems for logging and configuration, and then it also provides a complete security infrastructure for you. All of these things that you need if you're going to build an enterprise application. And then from a Jakarta EE point of view, or Java EE point of view, it also provides those APIs, which are industry standard, and which basically allow your application to utilize these services. So obviously Jakarta EE provides, for example, the Java Persistence API, which allows you to write and read data from a database, which then uses underlying the data source implementations that are within the application server. And basically using the Java EE API will map your data into rows in the database and use the data source to connect to that database. There are other things that, over and above the single instance of an application server that a managed runtime or application server will provide. So that also includes the ability to do high availability. So, clustering capabilities, ability to store data in one node and retrieve it from another node. Many different enterprise functionality is provided by the managed runtime. So it's a bit like an operating system is, but for server-side applications. And then that sits on top of some compute infrastructure. And over the past, few years, that compute infrastructure has become more and more diverse. We've moved away from bare metal servers to virtual machines, through to containers, through to container orchestration in Kubernetes, or cloud, cloud platforms, or even container runtimes, based on like Azure container instances. But all of that, from an application server or managed runtime perspective, is just compute infrastructure. And to a large extent, it's the role of the application server to hide the complexity of all that away from you as an application developer. So your job is to write the application, use the Jakarta EE or microprofile APIs, and then gain the benefits of all this functionality that's provided for you. So using that sort of definition, many other runtimes that would claim that application servers are heavy and slow are also effectively the same thing. And we'll look at that in a couple of deployment model slides. So in a traditional application server, which is the left-hand side, what you do is you take your application and you go through a step whereby you deploy it to the application server, the application runtime. And that is, that's how you would do that in Payara server on a domain. You would go through the administration console, you would upload your application, and then you'd hit deploy, and it would basically slot it into the runtime and execute it. Similar for WebLogic or JBoss or any of the other Jakarta EE, Java EE application servers. But then there's another model which is evolving at the moment, or has been around for a while, which is a fat jar. So in this model, what we do is we take our application and we package it up tightly with our runtime, our managed runtime. And then we can run it through Java-jar, and that will run our application and bootstrap the runtime at the same time. So this is, very, very similar, to be honest. It's just a packaging mechanism to a traditional application server. All you're doing really is you are combining your application with your runtime and creating a single artifact. And we'll see later, I have a very small demo of Payara Micro, where you can do the same thing in Payara Micro. But what we have is, semantically, it's effectively the same thing. The difference tends to be is that within a fat jar model, in some runtimes, it's possible to pick and choose the components and self-assembly your runtime. Whereas typically in a Java EE, Jakarta EE model with Payara, then your runtime will be versioned and be a specific version of the Payara. So you're not going to go around and choose which security components you've got or what data source implementation you're going to use, or which metrics provider and which networking library, whereas some other runtimes will allow you that freedom of choice, if you like, but it will require a level of self-assembly. And then there's things like Spring Boot, which have been built on top of that, which make or opinionated decisions on what those components should be. And from a sort of runtime perspective, some people favor the fat jar because that gives you a single artifact, and then others would Adam Beam would call a thin wire, where you deploy a very small application on top of a managed runtime. And we'll explore that in the next slide. So there's one advantage of the deployment sort of process, if you like, or the separation of the runtime layer from your application, is that when you go in to start looking at containers and how you're building container images so that they can be executed on any container orchestrator like Kubernetes, is that there's advantages to separating out your application layer from your application server or managed runtime or whatever you want to call it, or for framework. So typically within containers you have a number of layers. So you will have a base layer, which is obviously the operating system and however you've configured your operating system. Then you will have the runtime. So at this point, for example, if this was Payara Micro, you could layer a specific version of Micro on top of the base operating system layers, and then you can then just add the application code as a single layer. And the benefits of this is that the runtime layer and the operating system layers tend to be pretty stable and can be pretty big. Whereas the application, especially during development or pre-production and things, may go through a lot of frequent changes. And the way container images are built up, they are basically built up in layers, so the build time is much faster if you just pushing slight changes to a very thin layer than if you were pushing the whole thing over and over again every time you make a change. So if you're combining into a fat jar, for instance, that could be quite large, and then you would be pushing that larger change over and over. So the actual application server split with your application has some advantages if you're building these sort of images. So there's a big advantage of having a managed runtime like an application server. The first thing is, there's no self-assembly. Payara server or Payara Micro come with a version set of everything that all works together, has all been certified, and all runs against the Java EE TCKs and is a compatible implementation of Jakarta EE. So you don't have to assemble a runtime from various parts. It's also versioned, so from that perspective and from security patching perspective, if you have different layers, then if there is say there was a problem in something that is contained within Payara Micro or Payara Server, like a security alert on some component that we ship, then that if you upgrade just that layer to the latest version of Payara, then you're going to hit that. You're going to basically solve those security issues. That's much more tricky if you are packaging a fat jar yourself from very much different components, especially when these things have gone into production. And it's possible that the original development team that packaged up that fat jar has moved on. And then because we are a managed runtime, there's a lot of capabilities we can provide baked into the server itself. So we can provide monitoring, we can provide health checking, we can provide high availability, scalability. And it allows basically you as a developer to focus on just building your application and not the infrastructure. So moving on to this slide, basically one of the great advantages of an application server is that split between what is the runtime and what is your application. For example, As we move into things that we're sort of launching soon in like Payara Cloud, but just in general, the act of taking the application, separating from the runtime means the runtime can do a lot of hiding of complexity. For example, if you were going to package up a WAR file within a fat jar and deploy to Kubernetes, then you have to worry about one, creating that fat jar, but then you need to worry about creating your Docker files, building your Docker container images, writing your YAML files for creating your pods, and then interacting and controlling that through the Kubernetes API. When you move to something like Payara Server or Payara Cloud, and we got further, when we move into the cloud native questions next week, we'll explore this a lot further. Then there's a lot of things that the runtime can do, which isolates you from a lot of this complexity. For example, Payara Server itself, if you run that onto a cloud provider using like VM instances, then it will automatically cluster. It's been built and designed so that you don't have to configure anything special to run on Azure or AWS. And similar, we can provide things like Helm charts and to provide and allow you to build out into Kubernetes like a Payara domain. We can also provide things like Kubernetes operators, which we can provide and control your application. So we can do a lot of that work in an application server so that you don't have to worry about it as a developer. So that is the what is an application server portion of answering that question. So what we're really talking about is separating application from runtime. And let's move on to what is heavy. So often Java EE gets accused of being heavy. So I'm just going to explore what does that actually mean. So there's four things I think that possibly could mean. One is memory usage. So people claim that Java EE uses lots of memory, or application servers use lots of memory. And as we'll see a bit later, that isn't necessarily true. And from my experience, I spent many years in the field as a consultant. Application working sets, which what I mean by is the amount of memory your application is going to use is going to typically dwarf the memory used by the server itself. So you're going to want to keep stuff. Your working set is going to depend on how much data you need to hit in a single transaction or a single request, and that will typically be large compared to the application server, which we'll see in a later slide. Next is CPU usage. There's no reason why a runtime is going to add a lot of CPU over and above your raw algorithmic performance. It does some work for plumbing, obviously, but that typically is quite small. So again, when I used to be consulting, people would go, oh, this application server is really slow, my request's taking 2 or 3 seconds. However, if you build a hello world application that utilizes all the layers of Java EE, for example, typically you will get that running in, the request processing time for that would be 10 to 20 milliseconds. So we used to say basically to consult, when we were consulting to customers, that, okay, well, I can, the application server overhead may be 10, 20 milliseconds on your 2 or 3 second request. So we really need to look where the rest of the time's happening in your application. So CPU usage and that raw performance is not typically large on a Java EE application server. So maybe it's deployment size or installation size that people say is heavy. So when we come to deployment size, typically, because we separate the application server from the application, deployment sizes for Java EE are quite small. A reasonable size application maybe, it depends how many third-party dependencies you package. If you used raw Java EE APIs, for example, maybe a Hello World REST application, which we'll see, then that could be only a few kilobytes in size. So it's not deployment size that's going to be heavy. It depends on how many third-party dependencies you use. Typically for other runtimes where you're going to package up and your application runtime along with your application, then deployment size will typically be larger than a Jakarta EE deployment. And then the installation size, people talk about application servers having gigabytes of installation, and we'll see with something like Payara Micro that's just not true anymore. These have been shrunk down to be really small. So I basically checked this. So how does Jakarta EE compare? So this is not really I looked at basically Spring Boot 2 and Payara Micro. We took Pet Store, which is a Java EE standard, and Pet Clinic, which is a Spring standard application, and built them and compared. Now this is not one. What I'm trying not to do here is beat up Jakarta EE versus Spring, because both are actually very small. So if you look at a Spring Boot Pet Clinic, the file size when you build it is between 50 and 80 meg, depending on what you choose to be in your runtime. If you choose the lowest number of services, then it'll be 50. If you add things like WebSockets and REST and things, then it's going to get up to around the 80 megabyte size. Then when you boot that up, it'll boot up in 2 to 9 seconds. And if you do a heap dump, have a look at the heap usage, then it'll be using around 30 to 50 megabytes. And that Spring Boot application, if you hit a REST endpoint, will probably do around 2,000 to 3,000 requests per second. A bit of typo in there. So it's fast, it's small, and it boots quick. But if you take a modern runtime also like Payara Micro 5 and take that Pet Store application, so the Pet Store application has REST endpoints and those things in it, as well as a JSF application. Again, the application itself is around 8 megs, and Payara Micro is around close to 80 megabytes, just a bit under. So that would be about 88 megs. It's going to be a little bit bigger than Spring Boot, but nothing that is by any means huge in the scale of things in this day and age. And again, its heap usage is going to be between 70 meg and 45 meg when you boot it up. If you hit it with a performance tool, and what happens in both of them is basically the web session sizes, web sessions start gathering and they start using the majority of the heap. So again, it's the application usage rather than the runtime. And similar, Payara Micro, empty will boot in a couple of seconds. You add in the Pet Store application, and then it's probably going to boot in 10 to 15, depending on CPU. And again, similarly, it does 2,000 to 3,000 requests per second. Many frameworks do similar sort of 2,000 to 3,000 requests per second. So actually, and that's on a single instance on a basic PC computer. So all I'm trying to say here, I say I'm not beating up Spring versus Java EE, but what I'm saying is both are incredibly small nowadays. Server-side infrastructure and application servers and runtimes are very small. You use way much less resources than your browser is going to do running JavaScript. So both of them, as I say, are very small and it's very comparable. This is basically a heap dump from Payara Micro after starting up the Pet Store application. And this has gone through Eclipse Memory Analyzer Toolkit. So let's all look at the question of what do when people say Java is slow. And again, I'll go through this quite quickly because it can mean many different things. So do you mean response time? Well, most of the response time, to be honest, in real applications is used by you as a developer, and that is where the response time goes. As you can see, both Spring Boot and Payara Micro hitting a basic hello REST endpoint will do 2,000 to 3,000 requests a second. So we're talking tens of milliseconds. So when we have a performance problem, then we need to look at, is it an algorithmic performance problem, as in one request is slow, or is it a scalability issue? One request is fast, but thousands of concurrent requests are slow. And that's one of the first things. And there's a lot of capabilities in application servers to provide horizontal scalability. And then we also look at boot time. Is it that boot time slow? I mean, Payara Micro on an application will probably boot in between 2 and 10, 15 seconds. It depends what your application is and how much it is. And it's similar to other runtimes. If you add more and more stuff in there, then it's going to be slower. There are things that, if you go to Growl VM and native compilation, there are things that will boot an order of magnitude faster than that. But does it really matter is the question you have to ask yourself to rewrite your application and to go from 2 seconds to a few seconds, from a few seconds, sorry, to a few hundred milliseconds. And the application, the actual answer to that question is probably not. So people often use the sort of model of lambdas or something like that. But the reality is most of the lambda or functions cloud services will keep your function hanging around for tens of seconds before it starts passivating it or shutting it off. So boot time in reality is typically not that important. And again, in my view, that they're fast, even in a few tens of seconds, if the worst case. Then we have build time. Well, building a thin WAR is much faster than building, a full container with all the different layers from scratch. So build time in Jakarta EE tends to be really, really quick. And then again, we have like deployment time, which is how fast does it deploy an application. And again, this may take a few seconds, up to tens of seconds, depending on what you put in your application. The more you can use just the Java EE APIs, the faster your deployment will be. So the other thing, obviously, we talked about performance. Most Java EE application servers out of the box will also then give you horizontal scalability. And what I mean by horizontal scalability is it means, we add multiple instances. Both Payara Server, Payara Micro will provide auto clustering and all the things you will need for horizontal scalability without you having to do any work. So whether that's scaling on multiple pods, pod scaler in Kubernetes, we provide that capability to cluster on a Kubernetes infrastructure, or whether it's literally just running another Java process on another physical machine. And again, because we have a managed runtime, we can provide that functionality for you and provide that capability. So, so my conclusion really is Java EE is not heavy. It's comparable to others, and all of them, no matter which runtime or application server you choose, a lot of the overhead will actually come from your application itself. So whether that's memory, CPU usage, disk space usage, whatever else you're talking about, often it's the application that will be the dominant factor in any overhead of heavy or slowness. There's been a lot of work done on runtimes, not just Jakarta EE, Java EE runtimes, to make them smaller and smaller and smaller. And then where we are now, both in Java EE and in Spring, is that they are incredibly small compared to applications. So the whole point of Java EE is to separate that application and from your runtime. And then the point of what we're trying to do in Payara is we're trying to set this up so that you as a developer, all you need to do is worry about building your application. And we're building runtimes that will basically span from Payara Micro, which is really small. I'd say it's about 80 megabytes as a download, and that covers the whole of the Jakarta EE web profile APIs, plus a bunch of others that are useful, like batch and concurrency and JMS client. And that can run on very small edge servers or Raspberry Pis, so it's, I could say, a very small application server. Then we go through to Payara Server, which is a traditional domain mode where you have an admin and you manage many different server instances, and that is designed to work right across from bare metal servers through to Kubernetes. And then coming forward, later in this year, we'll be launching Payara Cloud, which effectively runs on top of Kubernetes, but also will run in multiple Kubernetes clusters and support deploying to multiple Kubernetes clusters. And we can do that because we separate the application from the infrastructure. And we strive all the time to make the infrastructure as small and lightweight and as fast as possible. So, any questions, Jaden?
Yes, we did have one from Ahmed. He asks, can we use Payara Micro to deploy a monolithic application on container platform, or is it designed only for small microservices?
No, it's not designed only for small microservices. You can take any application and deploy it onto Payara Micro that is just uses web profile APIs. So you could take a JSF application, for example, that is, a monolith, to say, for want of a better word, and that will run fine on Payara Micro. For example, in those slides, we were using the pet store application, and that runs fine. And then you can run that in a container. You could run it on Kubernetes. You could package it up in a single jar, because Payara Micro supports creating a fat jar if that's what you want. And then you can run it on any of this infrastructure. We explore that actually a bit more in the next webinar, because we're looking at what is cloud native in that, and that will look at those sort of deployment models.
Okay. Yeah, feel free to ask any other questions, guys, just in the chat or in the Q&A section. We'll give it a minute. Otherwise, we'll finish up.
Stop sharing.
There we go. Renee asks, how can I reduce the boot time of a Payara Micro application? Oh, this is a common one as well.
Okay. We have some capabilities in there to do what's called class data sharing and warming up. So we have some blogs about it, which we can probably find and send out. If you can do that, Jaden.
Yeah, I'll do it now. The class data sharing, yeah.
Yeah, we have some capabilities designed for containers where if you're building a container, you can warm up the application first, and that will do basically build up a class data sharing repository, and that can speed it up, especially if you run multiple instances of Micro. You can basically, if you can shrink down your deployment. So our current view is that there's some work we can do to get it down a little bit more, but a few seconds from our perspective is fine. We're never going to hit a native compiled level of boot, because we can't do that, because Java EE currently that will be unable to do that. So the best way really is to class data share, use the warm-up take capabilities, build the jar. You can also, you don't have to deploy every time. It has a command line called root_dir. What that does is effectively builds an installation. So you can run Payara Micro with deploy pointing to root_dir, root directory, and then next time you run Payara Micro, you don't need to specify the deploy command, because it's effectively running with the application pre-deployed, and that can speed up things as well. Okay.
Okay. I have a few things. I'm just going to put those notes in the chat, but while I'm doing that, we can answer a few more questions. Stuart asks, can you say more about Payara Cloud, or is that in a future talk? Will it only be for enterprise customers? In brackets, fair enough if it is, no implied criticism in this question. Okay,
so Payara Cloud is effectively going to be a Java EE, Jakarta EE platform as a service that we're building on top of Azure. So we got quite a lot of webinars about it already, so some of them will be recorded, and we will talk about it in the Cloud Native webinar. And what it effectively does is it allows you to take a WAR file, go to Payara.cloud, upload the WAR file, and deploy it onto Azure, just like you would if you were, like, say, going to an administration console of a normal application server. And basically what it does is it hides all the Kubernetes complexity. In fact, you don't care that it's running on Kubernetes, or fundamentally. Your application will get deployed and you'll get given a URL and you can access it. So it's definitely not only available to enterprise customers, because it's going to be a platform as a service that we provide to you. So you'll be able to sign up, use it in the same way as you would, say, for any Azure service, except you have to come through our website. And so we'll talk a little bit about more about it in the next webinar. I know Adam Bean has done some demos of it as well. And so, yeah, just watch Payara. There'll be more information about it.
Okay, brilliant. I've just shared a presentation Rudy actually just did recently on class data sharing.
Okay.
So I've just put that in the chat. Anonymous
attendee. Share to some Payara Cloud demos that are out there, I think, because some like actually live sort of demos, isn't there?
Okay, bro. Yeah, we'll do. Anonymous attendee asks, will the recording of the event be available on your YouTube channel? Yes, it will be. So what we're doing is we're just giving people a chance to catch back up. So if you've registered, it will be uploaded to the cloud where you can rewatch if you've missed it. And then we will upload the next talk in about a week. So last week's one will be available on our YouTube channel in just a few days, just after this one. So we'll just be working a week ahead of ourselves. Dirk Steinkamp asks, regarding developer joy, smiley face, are there any plans to improve hot code swap capabilities in Payara or Jakarta EE in general? JRebel claims to provide that. Quarkus has special support too.
There are plans. I mean, we do have some improvements to hot swap agents. We need to find the links to send that over, because we have got work with Java Hot Swap Agent. Also, some things that people don't realize you can do. So Payara Micro supports exploded deployments. So you can actually deploy a directory in Payara Micro, which is an exploded directory, and you can touch files in there and it will automatically refresh. You can also, do that in Payara server as well. It can deploy exploded directories. You can use a touch file, and which is what a lot of IDEs do, to refresh the application without you having to go through the deploy cycle. But there is hot swap work going on as well.
Yeah, I believe we've got some blogs from a while ago on hot swap. I'll see if I can find. Oh, there we go. Rudy is on the case.
Yeah, I think that's the one. So we are working on that. We're aware of it. Some stuff will need to go into Jakarta EE as well, I think, to have better support. But there are things that I suppose that aren't that obvious, that people don't know exist, that we need to promote a bit more.
Okay, that is all our questions at the minute, I believe.
Okay. So we have another webinar same time next week. That one's looking at Kubernetes, and basically I'm planning to look at, well, it's looking at cloud native. So I'm planning to look at various deployment models on public cloud, right from VMs with scale sets through to deploying onto container instances. So and that will also include some Kubernetes stuff. It's not all about Kubernetes.
I've put the link further up where people can get further information on the missed talks, including the one next week, as well as sort of links to register, as well as our meetup page where you can register there as well. And I've just put a little bit of a description of the next talk for those who might be interested. Otherwise, thank you all very much for joining us. Any further questions, please feel free to go to the website and email us, or questions through our social media, and we'll do our best to get back to you.
Okay, thanks.
Thank you very much. Cheers. Bye.
Bye.